Imagine waiting eagerly for a rocket launch, only to have it canceled not once, but twice, due to a stubborn technical glitch. That's exactly what happened with the ViaSat 3 F2 mission, which was grounded again because of a pesky issue with the Atlas V booster's liquid oxygen vent valve. But here's where it gets even more frustrating. This isn't just a minor delay. It's a reminder of how even the smallest component can derail a massive operation. Let's dive into what went wrong and why it matters. Update as of November 6th, 9:10 p.m. EST, 0210 UTC. United Launch Alliance has officially scrubbed the launch and is now eyeing a new date, yet to be announced. This marks the second consecutive night the mission has been halted, leaving space enthusiasts and industry watchers alike scratching their heads. The Atlas V rocket, poised to deliver the ViaSat 3 F2 satellite into orbit, was set to lift off from Cape Canaveral Space Force Station's Pad 41 at 10:16 p.m. EST, 0316 UTC. However, the same valve problem that thwarted Wednesday's attempt persisted into Thursday, forcing launch director James Whalen to call it off again. During Wednesday's final pre-launch checks, the vent valve on the first stage's liquid oxygen tank malfunctioned, and despite efforts to resolve it, the issue resurfaced. ULA confirmed the scrub in a statement, noting that the team will thoroughly inspect the hardware before setting a new launch date. And this is the part most people miss. The countdown for Thursday's attempt had already begun by 3 p.m. EST at ULA's Advanced Spaceflight Operations Center, ASOC, located 4 miles south of the launch pad. The Centaur upper stage's liquid oxygen tank was pressurized, and the booster was being loaded with liquid oxygen, when the decision to scrub was made around 9 p.m. Eastern Standard Time. Adding to the challenge, Cape Canaveral's weather wasn't exactly cooperating, with overcast skies, thick clouds, and rain showers. Launch Weather Officer Brian Belson from the 45th Weather Squadron gave the mission only a 50-50 chance of meeting weather criteria, citing the clouds and rain as major concerns. Encased within the rocket's 5.4-meter payload fairing, the 6-metric-ton ViaSat 3 F2 satellite, built by Boeing, awaits its journey to geostationary transfer orbit. Once launched, the Atlas V Centaur upper stage will perform 3 burns, consuming most of its hydrogen fuel, to propel the satellite into position. This process, known as minimum residual shutdown, maximizes the satellite's velocity upon deployment 3.5 hours into flight, potentially extending its operational lifespan. But here's where it gets controversial. Is this method of fuel management truly the most efficient? Or are there untapped alternatives that could further enhance satellite longevity? We'd love to hear your thoughts in the comments. ViaSat 3 F2 is the second satellite in the ViaSat 3 series. Following the 2023 launch of ViaSat 3 F1 by a SpaceX Falcon Heavy, however, F1 encountered antenna issues that delayed service and reduced capacity, a setback Viasat hopes to avoid this time. Once operational, F2 will bolster the company's Ka-band network, adding over 1 terabit per second TBPS of capacity across the Americas. After months of on-orbit testing at 79 degrees west longitude, the satellite is expected to begin service in early 2026. As we await the next launch attempt, one thing is clear. Space missions are a delicate balance of precision engineering and patience. What do you think? Is ULA's cautious approach justified, or should they push harder to meet deadlines? Let us know your take below.